Okay, so for this class we're going to talk about systems analysis and design. So far we've touched on how software is developed and of course, hardware, software, cloud computing, etc. In this lecture what we're going to talk about is the entire process of going from a business level problem to a deployed system. And so we're going to focus on these steps at its base as a kind of a waterfall process where one step must precede another. And then next week we're going to talk about this notion of iterative development where these steps get deployed in a more iterative fashion. Okay, and so what is systems analysis and design? So as an overview, it's a process that consists of the following general steps. Investigation, feasibility analysis, the identification of problems, opportunities, and objectives, requirements analysis, where we determine human information requirements and analyze what the system can do, systems design, where you design the recommended system, systems implementation, where you actually develop and document the system, and then systems maintenance, where you're maintaining and upgrading the implemented system. And then lastly, systems review, where you're reviewing the usefulness of the system over time and potentially restarting this whole process. So how is systems analysis and design initiated? Well, we begin by identifying problems with the existing system or lack of an existing system. We look at whether or not there's a desire to exploit a new business opportunity. We check to see whether there might be an uptick in competition. We also investigate whether or not people might want to make more effective use of organizational information. There also might have been a merger or acquisition of a company. Maybe there was a change in the market or external environment for which the company needs to adapt, or there were changes in laws or regulations for which an information system may need to comply. So this leads to a perception and summarization of a problem, and this initiates the systems development process. And in many cases, someone in the role of being a systems analyst begins this actual process. So let's look a little bit more about the role of a systems analyst. This picture to the right depicts technology systems at differing levels of an organization. And we have some acronyms defined here, which are not explained otherwise, so I just want to define them real quick. You have different types of systems, expert support systems, group decision support systems, and computer-supported collaborative work systems. These are an example of systems that exist at differing levels of the organization. So as we move from the bottom to the top, of this diagram, each level, as we go from operational to knowledge to, a higher level to a strategic level, we move to a higher level of decision support of the role that a different type of system can do for us, of the duty that a different type of system can do for us. So the point of this is that the systems analyst can't just be involved in one of these levels. It has to be involved at multiple levels. Being a systems analyst is not just about technology. It's about the confluence of business and technology. And so the systems analyst must determine the type of system that will best support the organization's needs and wherever that system may sit. So let's look some more at the role of the systems analyst. The quality of the systems analyst is that they have to have many qualities, but some of them here are they must be able to work with those in the business in many different capacities. They also must be well-versed in technologies, and they must be able to equate technology with business problems. So in other words, they need to understand the issues of the business and what technology can best be used to solve these issues. So in general, I like to think of the systems analyst having three primary roles. They're a consultant, people who provide systematic expertise in a particular issue with an understanding of the business issues. They're also a technology and business process expert, in line with that. And, inevitably you're engaging in these types of things to be an agent of change. So that's what a systems analyst has to be, is a change agent. So these types of, just coincidentally, or not so coincidentally, these types of business technology professionals are actually usually very well-paid individuals. So let's take a little bit of a look at the visual of a conventional systems development life cycle. we've got what we just defined in the other slide, where you've got step one, you identify problems and opportunities, objectives. Step two, you determine the requirements, analyze system needs in step three. Step four, you design the recommended system. Step five, you actually do it. You develop and you document software. And then in step six, you're actually testing and maintaining the system. And then, of course, there's the review at the very last step, which isn't in this diagram, but it's kind of incorporated into step six. So moving on to the next slide, let's take a look at some of these phase steps in depth. So systems investigation is the first phase. So the first phase in the development of a new or modified its principal purpose is to identify potential problems and opportunities and consider them in light of the strategic and operational goals of the company. So, understand the business problem, and then understand what types of technology could potentially be used, and also you're looking to see whether or not the company can actually do this. Do you have the expertise in-house? Do you have the time? Do you have other resources? So this phase also identifies who participates in the project. What members of the development team and of the business should participate in the investigation phase, into other phases of the project needs to be determined in the investigation phase. So, additionally, and this is much in line with your group projects, a feasibility analysis is also conducted. So we determine what's feasible or capable of being achieved, and you do it from kind of the loft perspective, which is legal, operations, financial, and technical. And so the output of this phase is an actual investigation that explains the business problem, the objectives to solving it, inputs, outputs, and why it makes sense to actually solve this problem now. Why should the business be doing it now? So let's take a more in-depth look at who participates in systems investigation. Company stakeholders is one, people who, either themselves or through the organization they represent ultimately benefit from the systems development project. Users, people who will interact with the system regularly. The systems analyst, the professional who specializes in analyzing and designing the business systems. People who actually focus on the implementation side, the programmers, the specialists responsible for modifying or developing the programs to satisfy user requirements. And there's also many more, but the point is the systems analyst must determine who they are, and you have to do this in the investigation phase. You have to involve people early on as much as you can. So moving on to the next slide, looking at a bit more about systems investigation, you also have to align corporate and information systems goals. The systems analysis, design, development, etc. is usually related somehow to a competitive advantage that's trying to be achieved. So it's good practice to find this relationship when investigating whether or not it is feasible to develop the system. So take the time to align corporate and information systems goals. So this will allow you to be able to speak to multiple audiences about the feasibility of the project. The developers, the programmers, are going to care in a totally different capacity than the CEO or the CIO of the company. So moving along with more about systems investigation, you also have to establish objectives for systems development. So during this phase, we also need to codify what the overall objectives of the system will be. This will be later refined in the systems analysis phase. So we need to define the overall performance and cost objectives, determine what the quality, usefulness, accuracy, and speed of information is needed to actually make the effort successful. And also one thing that's really important that needs to be done here is to define the success and or failure. And so in an overarching sense, you have to define what it means to be successful, what does the system need to do to be successful, and in a concise manner, codify that, document that, and then also, do it in such a way that you also inextricably define what it means to not be successful. So you can do this using critical success factors by naming your CSFs. What are the factors that will make the system essential to the success of a functional area of the organization? So moving on to the next slide and the next phase, let's talk about systems analysis. So this is probably the most intense phase of the systems analysis and development process, the SAND process. So in this phase, you try to accomplish the following overall objectives. You gather data on the existing system that you seek to improve, technical, non-technical. You determine the functional requirements. You actually declare what those are going to be, such as, I kind of put this example there, the system shall do X. You also provide a cost-benefit analysis of technological alternatives to solve the problem. And then you align your feasibility analysis with each of these alternatives because some may be more feasible than others. Okay, so let's move on to the next slide here, where we talk about the components of systems analysis. And probably the most extensive one is that of requirements development, or requirements engineering. This is the principal activity. So in this one, we seek additional information to clarify the problems and needs identified in the systems investigation phase. We also identify all known sources of data, internal and external. We collect that data and use that to develop requirements. And so, this is not in your book. This is, found in some other reading material that I've, a lot of stuff that I've read on this topic. As an information systems professor, you read a lot about systems analysis and design, and I've taken many classes. And when you employ it in practice, it's actually a little bit different, and I wanted to offer some of that insight here. And so what I put is, a link to the page, but also 5 principles for writing good requirements. So the first principle is it has to be necessary. It has to be needed, right? And that has to be clearly stated in how you write these requirements. It also has to be verifiable, whether or not you can determine whether or not the actual requirement can be met or not met. It has to be achievable. It has to be something that actually can be done within the scope of the project. It also has to be simple, concise, and easily understood. Usually requirement specifications, the actual requirements, are very concise, a few sentences long, a sentence or two long, and they're written in discrete components such as that. It also has to be unique. It can't be duplicated by any other requirement or overlap. You want it to, it might a little bit, but you want it to overlap as little as possible with other requirements. And it also has to be traceable by assigning some sort of a number or a nomenclature, a way of tracking those requirements. So let's move on to the next slide, which talks about another component of systems analysis, which is modeling. So in this phase, in systems analysis, we model the following things, and we've talked a little bit about this stuff. We model the data entities, attributes, and relationships in the system, which is the ERD model. And then we also depict things in terms of activity flow or sequences of user actions that get taken when using the system. So we model those two things, and then we also want to model a more activity-oriented pictorial, or provide a more activity-oriented pictorial of the actual flow of data in and out of the system. So data is modified, using an entity, or modeled, using an entity relationship diagram. Activities, inflows, outflows, things like that are modeled via a data flow diagram, a sequence diagram, or an activity model. And so for your project, you can do all these using Draw.io, a tool I showed you before. And you also have to determine which ones are important for your project. I would contest that probably all of them are very important because they all show different dimensions of what your project is going to be. So let's go on to the next slide here where I kind of give you a little bit of a picture of what these things look like. You've got your ERD in the upper left. You've got your sequence diagrams where at the very top of the sequence diagram you have your actors. And then you have the actions or the sequence of actions that they actually do. So they place an order. They go and they order food, for example, and then they get a return message that gives them notice of what they ordered, like a receipt or something like that. This is a very simple example, but this is the essence of what you do with a sequence diagram. In the bottom left, we have the data flow diagram, which is an arrow-based pictorial of what inflows and outflows with respect to your system. And in the bottom right, we have an activity diagram, which gives you another pictorial of the actual flow of what people do and how they interact with the system. So let's move on to the next slide and talk about systems analysis with respect to screen and report layouts. And this is another component, and the things you need to do with respect to this phase, and the reports you develop at this phase. We need to have mock-ups. We need to have single screens, navigation as you go from screen to screen, and we need to have a visual of what the reports are going to look like, what the outputs are going to look like. So that gives you a visual of what the inputs are going to look like, how you navigate from one input to the next, and what the final outputs are going to look like. So let's go now to the next phase of systems design. So in this phase, we specify and finalize what I refer to as the logical and physical design of the system. We've talked about these definitions before. The logical design of the system is a description of the functional requirements of the system, the logical architecture, and the physical design is a specification of the physical components of that system. And so systems design, what it basically does is take a lot of the stuff that you've developed during systems analysis and begin to finalize those things as you prepare for systems implementation or development. So you finalize your system's inputs and outputs, the user interfaces, the software, databases, networking, telecommunications, personnel, users of the system, who's going to be using it, and the procedures to use it and how users will navigate from end to end. So a lot of these things are specified in systems analysis, but inevitably this is a stepwise process where there's a constant state of review, and so you want to prepare things as much as possible to be ready for actual implementation. So in this class, we focus a little bit on implementation. You do some of the stuff in Access, but what we really want you to focus on is finding ways to analyze the system, understanding business problems, and then moving towards technology. So we really spend most of that time on analysis and design. So going more into systems design, there's questions that need to be answered during this phase that are a little more detailed than what you did in systems analysis, such as, what are the queries used to generate the base set of reports? What is the full description of all database components? We also need to identify a full description of all database components. Data inflows and outflows. We need to know the full path of data inflows and outflows for the system. More about those and there needs to be more specificity with respect to those outflows as with respect to the essential reports that satisfy the requirements for the system. What security procedures the system will employ, such as like how people will log in, how we track people's identity as they navigate through the system, and how people actually establish that identity. Another thing we need to identify is the environmental considerations. What is the actual physical layout going to be? So let's take a look at some more questions related to systems design that need to be answered, and I think this will help you greatly in your group project. Should you acquire or use cloud services for either software or database applications? Should you develop the software internally, buy a predefined software package to satisfy requirements, or work from open source package or closed source package that you can then take and customize and modify in one way or another? So also, you need to consider how you will prepare or train your users to use the system. How you will train those IS personnel to use the system and to actually train other personnel to maintain it. How will you prepare the physical site to host the system is another consideration, and also how you will get the initial set of data that you need to have in there so that people can actually begin to use this thing. Another question that needs to be answered is how the system will be installed, maintained, version upgrades, and deployed. What is the procedure to deploy the system, whether it's iteration 1 or iteration n? Another question is, how will the system be tested to actually satisfy the requirements, and how will you certify acceptance, particularly acceptance by the users of the system? Another question is, will the system be, what will the system be phased in? Will it be started in parallel with an existing system? Will a pilot project be started with a select group of users? How will you actually infuse this system into the organization? These are all questions that are essential that need to be answered during systems design and need to be answered also in your projects. So now let's move on to systems implementation. So in this phase, actual software development and database development this is where it gets done. Hardware is purchased and implemented based on the methodologies that you specified in analysis and design, and any and all physical, telecommunications, and networking requirements for the system are put into place. So, we don't talk a ton about systems implementation, in the general sense, because it's really about the technology at this point, because a working system is the goal at the end of this phase. So, some typical steps in the systems implementation. You have hardware acquisition, software acquisition, user preparation, the actual training, site preparation, preparing the data, actually installing and deploying it, testing, system startup, that initial system startup, and satisfying of user acceptance. So, in the previous slides, we covered in a question form every single one of these components. And so during design, you need to answer these questions so that there's as little questions as possible when you're in the implementation phase. That's the goal. Remove the questions and then go do it. That's kind of the essence of why they have come up with this waterfall approach to systems development. Now let's move on to some of the latter phases, which, not so coincidentally, things like systems maintenance, considerable time is spent during these phases, during the waterfall process, and we'll get into some of the detail as to why that is and some of the flaws of this process next week when we talk about iterative development, because iterative development is an incarnation of this base process that's been modified over the years to try and adapt for some of the shortcomings of waterfall development. But to understand iterative development, you have to understand this first. So that's why we're talking about it. And you really do need to understand the systems analysis and development process. It's essential to this course and to your projects. So let's talk about systems maintenance. And let's talk about them in the form of some questions. So things I think you need to answer. How will the system be adaptive, right? How will it be modified or upgraded? How will these upgrades actually happen? Will they be slipstream upgrades, patches, or new releases? And so, based on some research that one of these gentlemen I actually almost went to study under, Swanson, Ebert and Swanson is at UCLA, and I actually almost went there for my doctorate, so I do know him very well and see him at conferences. But way before I was considering a PhD, these two folks, Leentz and Swanson, did a lot of research on systems maintenance because it was occupying so much of developers and systems analysts' time, and they came up with 4 categories as to where that time was being spent and how to mitigate them. So let's talk about these categories. There's the adaptive category, where it's modifying, where the time spent is modifying the system to cope with changes in the software environment. And changes are inevitable. You have to embrace change, so they're always going to be happening. You have to design systems to be adaptive. The other dimension is perfective, where you're implementing new or changed user requirements which concern functional enhancements to the software. So basically you're trying to kind of perfect the software in the user's eyes. Then there's corrective action, where you're diagnosing and fixing errors, possibly the ones found by users. And then preventative action is a category where you're increasing software maintainability or reliability so that you can prevent problems in the future. And, we talked about some of the ways to do that in other classes, particularly when we talked about reusability. So we enact these questions in the systems maintenance phase, but we plan for them in the systems analysis and design phase. So let's go to the next slide, systems review. And this is, not something where a lot of time is spent, but it is very important because it is something that potentially restarts this whole cycle in long form when we're talking about the base waterfall development cycle, or in iterative fashion when we're talking about iterative development, which we'll talk about next week. So systems review is the final step of the development process. It's the process of analyzing systems to make sure they're operating as intended, and it's comparing the performance and benefits of the system as it was designed with actual performance and benefits of the system in operation. So it's comparing design with what actually happened. And as we've seen in waterfall development processes, conventional waterfall development processes, Because the process is so long, because so much time elapses between analysis, design, development, and maintenance, there are usually some pretty wide gaps. So those need to be reviewed. So there's a number of different types of review. And one is what we'll talk about is event-driven review, where it's a review triggered by a problem or opportunity, such as an error, a merger, acquisition, a new market for products, any event that may question the usefulness of the system, question who uses the system, questions the functionality or applicability of the system. That's an event-driven review. There's also time-driven reviews, where it's a review formed after a specified amount of time. This should always be done after you've implemented a system, without a doubt. Once people are using it in whatever way, you want to review after potentially short amounts of time, how people are using it and what its usefulness actually is based on what you thought. And then the last one is system software products, where it's actually components of technology, measures components, information systems, hardware, software, database, software performance, network systems, hardware, software, database, performance, telecommunications, and network systems. All of these are systems review. There's a lot of open source tools that do this, especially that should be undertaken, whether it's by an event JMeter is one of them that I can think of offhand, time periods, and many others, or constantly, continuously analyzing performance that can be used during. So that's all I have for this week with respect to systems analysis and design. This is the first part of a two-part lecture kind of series on systems analysis and design, where, like as I mentioned, we're going to talk about iterative development, which is quite honestly what most modern software development practices are using in this day and age. So we give you the basics in this week, and then we take those basics and we augment them with modern development processes that, if you're working with technology development organizations, you're quite likely to see. So until next time, hope you enjoyed the lecture. I apologize about any background noise, but I will see you soon.